We will start this lecture with this confidence. Notes from this lecture will be provided to you. Link is given below. Everything will be understood in an excellent way. And remember that 100% of your paper, whether it be for school, for pre-board, will be from this lecture. So learn attentively. I will make you understand very easily. First of all, what will be discussed today? Balancing a chemical reaction. We will teach you balancing it in excellent way. Types of reaction, 4 types of reaction are there, must be understood, as well as remember this. Heat in reaction, exothermic, endothermic, oxidation, reduction, these two will be topic inside it, and physical and chemical change. Let's start, bhai. You are ready? Wrote in the comment, I will win. Confident must be there, I will win. Your bhai is standing with you, don't stress. Starting with the first thing, bhai, what is chemical reaction? Nothing beta. Any such process which results into a new chemical, that is called chemical reaction. A process in which new chemical or chemicals are formed is called chemical reaction. Look at one example, like hydrogen gas react with oxygen gas to produce water under some condition. What happened? That hydrogen gas reacted with oxygen gas and produced what? Water. What is called chemical reaction. The two chemical mixed and a new chemical is produced. 2 new chemical or 3 new chemical produced. That's what we call chemical reaction. No questions come from this part. Second thing is, what is chemical equation? Now when you write the same reaction in the form of symbol, like you have seen hydrogen, which is written as H2, oxygen is written as O2, water is written as what? H2O. So when reaction is written in the form of symbol, we call it chemical equation. Simple representation of a chemical reaction with symbols and formula. Look at one more thing. Here you can see in bracket G, here also G, here L. So these things are written. What does this mean? When S is written in bracket, that means chemical is solid. L is written, so the bracket is chemical. What is water? The liquid. Either written G or upside down arrow like this is drawn. Then that thing is gas, like oxygen gas, hydrogen gas. 2 more things are written. Wrote AQ in the brackets. That means aqueous, means soluble in water. That chemical with AQ written beside it, it is soluble in water. Many times this is written in brackets. Look at this attentively. New things. PPT means precipitate. Either PPT or there will be written downward arrow will be drawn. This means whatever chemical this is, suppose writing PPT or downwards arrow, means this is insoluble in water. Precipitate, what? Insoluble in water. Aqueous, soluble in water. Precipitate or downward arrow, insoluble in water. Look at one more this thing, reactant and product. So things at the left hand sides, those are called reactant. Things at the right hand side of the equations, those are called product. Clear? The equation is shown like this with the symbols. This aqueous, this is precipitate, insoluble. This side reactants and this side products. Clear? Questions don't come from this part. Let's move further. Now I will teach you balancing, but before that many students get confused. If I ask to write the formula of aluminum chloride by the valencies and symbols which are remembered, let's have quick revision. This topic will be stronger for you. All right, everything forgotten. Suppose I ask you what is lead nitrate, then you don't remember. Let's have a quick revision. Sodium Na+1, potassium K+1, silver Ag+1, copper Cu1, Cu+1. Valencies of all this are 1 and plus. Now look at 2's. Magnesium Mg2+, calcium Ca2+, zinc Zn2+, iron 2 means this is called ferrous, Fe2+, copper 2, Cu2. What else? Lead 2, Pb2, barium Ba2+. Aluminium and ferric means third valency of iron. Where is it? Aluminium Al3+. Aluminium and iron's 2 valencies can be seen. One is ferrous +2, another one ferric +3. Only these you have to remember quickly. You already memorized many of this. Pause and memorize this quickly. Wrote in comments, I have memorized. This chapter will be easier for you. It will be done if you memorize. Do it, yeah. Do it, bhai. I will make, swear by your crush. Do it, do it. Giving me promises, I don't remember. You do it, bhai. All right, you have to memorize this also. This is negative anions. Do remember chloride Cl-1, bromide Br-1, oxide O2-, and memorize nitrate NO3 1-, hydroxide OH 1-, carbonate CO3 2-, sulfate SO4 2-. Pause and memorize this much. I swear you, bhai. Ha. Ha bhai, look bhaiya, I put swear on you. Now you have to do it. Master put swear on us. Let's see sodium chloride first. So sodium is written what? Na and +1. What is for chloride? Cl and -1. When it's equal to above, look, 1 plus means 1, 1 minus 18 means, that means 1. If it's equal, then cut it and write directly NaCl. Whenever valency is equal, 1, 1 written, 2, 2 written, 3, 3 written, cut it. Aluminum chloride. Look, what is it for Al? It's 3 plus. And chloride, Cl is what? -1. Now do one thing, it is not equal, so cross multiply it. This goes here and this here and leave plus minus. So what does it become? 1 comes below Al, no need to write it. 3 comes below AlCl3. Why to write 1 by 1 is just 1. So 1 below Al, 3 below Cl. Ferrous sulfide. Ferrous, Fe. What? 2 plus 1? Ferrous, iron 2. This, Fe 2 plus. Look at sulfate. SO4 2 minus. It is equal, so play the cut game. FeSO4. Lead nitrate. So look, lead, his Pb2 plus. Look attentively on lead, Pb2 plus nitrate. NO3 1 minus. Bhai, look now, it is not equal, it will cross multiply. So what will come below Pb? 1 will come. And what will comes below this whole? 2. This is NO3 full. What comes after this? 2. This goes here, this goes here. Pb1, what comes with the whole NO3? 2. Lead nitrate. So do practice like this. So one comment and tell us ferric oxide. What is the chemical formula of ferric oxide? Tell in comments. Everyone will comment by. Now we will study balancing the chemical equation. Whatever problem you had for balancing, today everything will be fixed. First thing, what is balancing? What? The number of atoms of each element in a chemical equation should be same on LHS and RHS. Means atoms on every element should be equal on LHS to RHS. How many A's here? 2. How many A's are there? 1. How many B's in? 2. How many B's are in there? 1. So if I put 2 here, then see, how many A's atoms in LHS? 2. 2 in RHS? 2. How many B's atom in LHS? 2. How many in RHS? 2. This is called balancing. But it is asked in CBSE 2025, and anyway it is asked that why is balancing done? It is asked in board, why balance? Balancing because total mass of reactant should be equal to total mass of product. Total mass on this side should be equal to total mass on this side. That's why every element's atoms should be equal. Like take an example, suppose mass of one atom and A is 2 gram. Then what is the mass of 2 atoms? 4 gram. Let mass of B's 1 atom be 3 gram. Then how much for 2 atom? 3 into 2, 6 gram. Come here. 1 atom of A is 2, 1 atom of B is 3. 2, 3, 5. 5 into 2, 10. Now mass of product 10 gram. Mass of reactant 10 gram. That's why it's balanced. Total mass of reactant should be equal to total mass of product. But why should even this happen? Why mass should be equal on both sides? So that law of conservation of mass remains valid. Law of conservation of mass. What does it say? Mass can neither be created nor be destroyed under ordinary condition. It may happen in extraordinary, but you must have read mass can either be created nor be destroyed. So that's why balancing is done. That can be asked in exam. Chalo bhai, now let's begin doing the balancing. Whenever a reaction comes to you for balance, then you have to abide by the rule. The rule is given in NCERT, hit and try. Hit and try and it will be balanced. No, master will not teach you guessing. The master will teach you a method. And by method, every reaction will be balanced. Chalo, what is method? First of all, balance the method. On both sides, metals should be equal. What are metals? Sodium, potassium, silver, copper, magnesium, zinc, calcium, iron, aluminum, lead, manganese, barium. Wherever these seen, first of all, balance these. Makes them equal. We will not make any table or etc. directly with method. We will make it smoky by. This is gunshot. First of all, metal. Then balance the non-metal. What are non-metals? Chlorine, bromine, sulfur, nitrogen, carbon, phosphorus. Then balancing this. After these two, you balance the oxygen. And in the end, balance the hydrogen. And keep repeating it till it's not balanced on both sides. Clear? First of all, what you have to do? Metal. If you see any of these things, then the non-metals, chlorine, bromine, sulfur. If you see one of these, then oxygen, then hydrogen, then repeat. Let's go, let's practice, we'll get better. Take this reaction. What do we have to balance first? Metal. Where is metal in this? Which is the metal? Which one? Iron is metal. Here one iron. How many is this? 3 irons. If we put 3 irons here, then metal is balanced. What is next? Non-metal. What? Chlorine, bromine, sulfur. Is there anything? There is no non-metal. We will see hydrogen, oxygen separately. There is no other non-metal. What is here? Oxygen. Now come. How many oxygen are there? 4. How many oxygen are there? 1. If I add 4 in here, will the oxygen be balanced? What is there after oxygen? Hydrogen. How many hydrogen are here? 4 2s are 8. How many are here? 2. If I add 4 here, will it be balanced? Check it once. Iron 3, 3 balanced. Oxygen 4, 4 balanced. Hydrogen 4 2s are 8, 4 2s are 8 balanced. Try this one on your own, then I'll do it. Chalo, pause it and try. Chalo, bhai, start. First of all, metal. Here, what is metal? Here, aluminium. Look carefully. This is aluminium metal. There is 2. Here is 1. Can I put 2 in front of it? Okay, balance. Next, non-metal. Who is non-metal? Who? Chlorine. How many chlorine is there? 1. Here, how many chlorine? 2 3s are 6. Here 6 and here 1. Let's directly put 6 here. It would be balanced. So, aluminium 2, 2 balanced. Chlorine 6, 6 balanced. What is next? Oxygen. Here is 3 oxygen and here 1. See here 3, there 1. If I put 3 here, then it will be balanced. Yes. Who is next? Hydrogen. How much hydrogen is here? 6. How many hydrogen is here? 3 into 2, 6. See, everything is balanced. Look attentively. 2 aluminum balanced. 6 chlorine, 2 into 3, 6 chlorine is balanced. 6 hydrogen, 3 into 2, 6 hydrogen balanced. 3 oxygen balanced. Say everything is clear. Let's move ahead. Next, look at this. Pause and try it yourself. Let's go, bhai. Metal first. What's metal among this? Copper. Here 2 copper, here 2 copper, here 1 copper. So 2, 2, 4. So should I put here 4? Balanced. Okay. Now non-metal. Which is non-metal? Sulfur. Sulfur here 1, here 1. Balanced. Now third is oxygen. Here is 1 oxygen. And how many oxygen here? 2. Here it is more and here less. So I have to put 2 here. Now 2 oxygen balanced. But now pay attention. As we put 2 here, copper gets ruined. By copper changed. Here 2 into 2, 4 and here 2, 6 and here copper 4. So whenever something gets damaged, then again start from step 1. That's why one thing was written here. Look here, one thing is written. Repeat until all atoms balanced. Anything anywhere is deteriorating from above, go back and change. Means as I put 2 here, copper deteriorates. 2 into 2, 4, 2, 6. Here 4. So now again let's start from beginning. Balance the metal first. 2 into 2, 4, 2, 6. Here put 6. Now again check non-metals. Sulfur, here is 1, here is 1 balanced. Now let's check oxygen. 2 oxygen, 2 oxygen. The whole equation was balanced. Whenever anything deteriorates, start again from step 1. Let's see the next one, this reaction. Now look at this cautiously. There are 2 metals here, barium and aluminium also. Whom to start with? Start with anyone. The answer will be the same. I will start with barium. Here 1 barium, here 1 barium. Balanced. Next, I have to catch the second metal, aluminium. 2 aluminiums here, only 1 aluminium there. I put 2 here, balanced. The 2 metals got balanced. Barium 1, 1 balanced. Aluminium 2, 2 balanced. Now non-metal. Which are non-metals in here? Chlorine is also there, sulfur is also there. So I will catch chlorine first. Here 2 chlorine, here are 6. Look, here are 2 chlorine there. 2 into 3, 6. What do I do? Should I put 3 before this? Is it right? 3 into 2, 6. 2 into 3, 6. But again, as we put 3 before it, metal deteriorates. As anything deteriorates, start again from step 1. What was step 1? Metal. Here are 3 barium. What should I put there? 3 barium, balanced. The second metal is aluminium. Where should I put aluminium? There is 2 aluminium, balanced. Next chlorine, 3 into 2, 6. 2 into 3, 6, balanced. Next is second non-metal, sulfur. Here is 3 sulfur. Here is also 3 sulfur, balanced. Next, oxygen. Here 4 3s are 12. If it's outside, then multiply. 4 3s are 12 oxygen. And here 3 4s are 12 oxygen. Everything is balanced. 3 barium, 3 barium, 2 aluminum, 2 aluminum, 6 chlorine, 6 chlorine, 3 sulfur, 3 sulfur, 3 4s are 12 oxygen, 3 4s are 12 oxygen. See the last one, it has come in CBSE 2025 and you picked my last year lectures. I have said this so many times that this reaction will occur in one or other form and it's balancing too. I made you practice and memorize and it came in board. So beta, whatever I'll tell you will come in board. I'll not tell what has come in board. I should be reverse of this. What I tell it would come from that. Come, let's start. First of all, metal. One lead is here, one lead is here. Balanced. Next, non-metal. Non-metal which are nitrogen. Oxygen will do later. Here are 2 nitrogen. Here is only 1 nitrogen. So should I put 2 here? Look, here is 2 nitrogen. I put 2 nitrogen here. Now catch oxygen. Here 2 3s are 6 oxygen and here 1 2 2s are 4, 6 to 6. 2 2s are 4 to 6 plus 7 oxygens are here this side. 2 2s are 4 to 6, 1 7 and here is 2 3s are 6. On this side oxygen should be increased. How? Putting 2 before this the only way. This increases too much but we don't have any other option. I can't increase less than that. At least 2 are to be put here. Here it lacked now. Here it was excess. So I put 2. Now putting 2 causes the same problem. That all the previous changes. So let's start from the beginning. Alright, put 2 before lead. Now everything what I related. Again, metal, lead. Here are 2 lead. Here is 1 lead. So I'll put 2 here. Balanced. We started from the beginning. Here 2 lead, balanced. Next is non-metal, nitrogen here. Here 2 was already there, 2 was came again, 2 2s are 4 nitrogen and here is 2 nitrogen. So we'll have to fix this. Come, let's fix it. Here is, let's write 4. Tell me is correct. 2 2s are 4 nitrogen. Last oxygen. 3 2s are 6, 6 2s are 12. 12 oxygen is here. Then look here, 2 oxygen, 4 2s are 8 and 2 10. 4 2s are 8, 2 10 and 10 2. 12 oxygen balanced. Now listen to one thing. This reaction is very important for your exam. Now it's only not about balancing. We have to study this reaction in detail. Its decomposition we study every time. That's why memorize any one coefficient in this selection. Remember any one thing. Remember that NO2 before. Memorize it. How much will be NO2? 4. As much as memorize NO2 4, the whole reaction will be balanced now on its own. So we do these kinds of when balancing, we memorize this style of reaction and it proves useful. That's the benefit of gunshot lecture. The NO2 carries 4. Whenever you see this reaction, lead nitrate, cell, PbO, NO2, put 4 at NO2. As we put 4 at NO2, everything else will be balanced on its own. Fix the 1 and the rest will get balanced. Alright, I will teach you these kinds of things. Let's practice some questions now. Look at CBSE 2025 questions. What is it asking? This came last year. It is asking to find out the value of PQRS. P is before this, A before Q, R before this, A before this, till the value of this. So pause and solve and comment the values are. It's easy. Let's start the metal. How many metals are here? 1 and here 2. So put 2 here. There is no non-metal. Next, oxygen. Here is 1 oxygen. Here 3 oxygens. Let's put 3 here, balanced. Next is hydrogen. 3 2s are 6. Here 2 is written. We'll put 3. 3 2s are 6. It's balanced. Tell me the value. I think P is this. This is Q. And this is R. And S is this. So P's value is 2. Q's value 3. And nothing written between R. That means it's 1. And S's value is 3. Tell me it's solved. Next, see a question from CBSE 2023. A total halwa. Same thing. It's one thing. Find the reaction of X, Y, Z. This reaction too would definitely come in some form of in your boards. In your pre-board or board, it will definitely come. So many sets of exam are made from this one, it's definitely there. Come, let's understand the balancing of this one. If you memorize this, you will memorize that HCl is balanced at 4. Only 2 or 3 things, won't tell you many things. In this one, MnO2, the HCl is balanced at 4. Leave it, let's solve this one now. What's the tension? Let's solve it. Start. Mn1, 1. It's balanced. First one is not metal. Metal is Mn, 1, 1 balanced. Next, it's non-metal. Non-metal who? Chlorine. Here is 1, here is 2 and 2. How much is it? 4. So here comes 4. Next is oxygen. Here it's 2 and there 1. Here it's 2. Can you see it? And there 1. So here we write 2. Next is hydrogen. Here it's 4 and here totals are 4. Everything is balanced. Check it once. 1 Mn, 1 Mn, 4 chlorine, 4 chlorine, 2 oxygen, 2 oxygen, 4 hydrogen, 4 hydrogen, balanced. Whose value have been asked? X. This will be the X, the one which is put before HCl. Y, the one before H2O. Z, the one in front of Cl2. This one is nothing in front of Cl2. What should we write? 1. This is the value of X, Y, Z. 4, 2 and 1. Clear? Let's go. Now see what they were asking for CBSE 2025. What are they asking? Why do we balance a chemical equation? Why do we balance? Total mass of reactants should be equal to total mass of product. Name and state the law just suggests the balancing of a chemical reaction. Tell me that law. Which law is that? Law of conservation of mass. State the law. Mass can neither be created nor be destroyed under ordinary conditions. This is called stating the law. I told you now, they have asked for that. It's not like that they're asking 2025. That's why I'm teaching. Last year they've asked it. I taught this one also. Acha, now they're saying balance this reaction. Will you do it? Okay. I'm giving you this one as homework. Balance this. Should we do it? Okay, let's do it. 1 zinc here, 3 zinc. Try it yourself. Pause it. So here is 3. Next, non-metal. What is non-metal? P, phosphorus. Here it's 1 phosphorus and here 2 phosphorus. So here I'll put 2. Next is oxygen. 2 2s are 8. Here 2 2s are 8. That's equal. Next is hydrogen. 2 3s are 6. Here it is 2. Can I put 3 here? 3 2s are 6. 3 2s are 6. Everything's balanced. 3 zinc balanced. 2 phosphorus balanced. 2 4s are 8 oxygen. 2 4s are 8 oxygen balanced. 2 3s are 6 hydrogen. 3 2s are 6 hydrogen. Tell me it's clear. No tables or etc. Metal, non-metal, oxygen, hydrogen. Every question will be solved. If anything goes wrong, begin it from the beginning. So by this was balancing. After this, what is characteristics of chemical equation? Questions generally don't come from this part. That what would you get to see in chemical reaction? Generally, we don't have questions from here in the board. What we all can see it in here? Fact can be seen, not facts. Facts. F-E-C-T-S. What? F means formation of precipitate. What is precipitate? We need to find some insoluble things in the reaction. Second is E. What is E? Evolution of a gas. Some gas is released, carbon dioxide, oxygen, sulfur dioxide, a gas is released. Third point is C. That is color is changed. The color is changed from green to blue, yellow to green. So in reaction, there can be also a change in color. Fourth thing is T. T means temperature change. That is, heat is increasing. Change in temperature will occur, heat will absorb, temperature will decrease, and the color will also change. Fifth thing is S. There should be a change in the state. Suppose the reactant is a liquid and the product you get gas. So from liquid to gas. So this is facts, characteristics, what we all can see. Formation of precipitate, evolution of gas, C color change, T temperature change, S state change. Questions don't come from here. Now we have to study types of chemical reaction. We have to study 4 types of chemical reaction. First one is combination reaction. It's simple. Combination reaction is when 2 reactants combine and become a single product. Here I have made it single product C. 2 reactants met, cut this, a single product C is made. Or 3 reactants combined and makes a single product X, right? Just I said X plus Y plus Z. And you, the final answer comes S. One single product should make, combined and become a single product. What is it? 2 or more reactant combine to form a single product. A reaction in which 2 or more reactants combine and finally form only one product. It's called combination reaction. Look at the first example, burning of a magnesium ribbon. NCERT also tells us. What happened, beta? We took magnesium ribbon and burn it into the fire. What happens when we burn it? Oxygen in the air combines with the magnesium. What is formed by combining magnesium and oxygen? Magnesium oxide, MgO. What it releases? Very much heat will release. Is clear? We took magnesium ribbon and we burned it. While burning, what did it absorb from the air? Oxygen. What is formed by combining magnesium and oxygen? MgO, magnesium oxide, along with heat. This magnesium oxide is a powder of white color. White powder. Do remember it. Heat is released along with it. Reaction in which beta heat is released. These type of reactions are called exothermic reaction. any reaction in which heat is being released, we call it exothermic reaction. Let's read the important points. Magnesium burns with dazzling white flame, very bright light. When it burns, then very bright light is released. Dazzling white flame is released. When you burn magnesium ribbon, dazzling white flames will be released. Next, a white MgO powder in watch glass. Watch glass means this both. What became in this? Magnesium and oxygen is combining. Magnesium oxide is become. How is it? White powder is formed. How is magnesium oxide? It forms white powder. Next, heat energy released. So temperature increases. Very much heat is released. Combination reaction is also there because two combine to form a single product, and it is also an exothermic reaction. Why? Because heat is released. Whenever heat is released, then it's an exothermic reaction. Will you remember it? Magnesium and oxygen combine, magnesium oxide is produced. Which color? White powder, and heat is releasing. Dazzling white light is released. White powder is formed. Heat energy is released. That's why it's exothermic as well as combination also. All right, look at the reaction must be balanced, otherwise you will not get full marks. 2 mg, 2 mg, 2 oxygen, balanced. Come, let's see the question. The first question is, why do we rub magnesium with sandpaper? Whenever we take magnesium ribbon, when it's rubbed with sandpaper, you must have seen this at home. When the labor comes, the first thing they rub the iron with the paper, with sandpaper. It is called ragmar. Whatever you say, sand, gas. Why do we rub it, beta? Because it's possible that there is a layer of magnesium oxide there. So we rub it and remove that layer. To remove any layer of magnesium oxide already present on the magnesium ribbon, it is possible that it's already a layer of oxide there. We clean it by rubbing. Why to keep magnesium ribbons away from your eye? Whenever burn that, keep it away from your eye. Why? Because dazzling white light, very bright light is released. And what can that very bright light do? If you look at it for a very long time, you will not be able to see anything for some time. Like it happens when you go to a very bright place and then come to a place where it's less light, you will not be able to see anything. That's why it must not be seen directly. Because the reaction is exothermic, one thing, heat is being released, and it's emits dazzling white light. So bright that you cannot see for a short time after looking at it. After you looking at it, you will not see anything for a short time. That's why it's not be looked directly. Question, CBSE 2025, what is it? Which, look, it came now. Select from the following statement which is not true about burning of magnesium. What is not true? It burns with dazzling white flame. True. A white powder is formed on burning magnesium oxide. True. It is endothermic reaction. False. What type? Exothermic. Heat is released. What is endo? We'll read it ahead. Exo is not. It's endo. It's heat absorbed. Don't worry. Read fourth. It's an example of combination reaction. This is true. This is true. This is true. One must be false, not true. So this is the one. You can understand this way also. Anyway, what is this? Exothermic. Let's move forward. Next, we will read Quicklime's reaction in water. What is quicklime? Calcium oxide. You must memorize it. Quicklime, calcium oxide. Remember two things. One is quicklime. What is lime? It's calcium. Quicklime, calcium oxide. When it combines with water, then CaOH whole twice, calcium hydroxide. This is called slaked lime. Slaked lime. Slaked lime. Look, lime means calcium. Look minutely in slake. Can you see lake? Lake means water. So calcium hydroxide. Water has come. Calcium hydroxide. Alright. So quicklime reacts with water. Then both combines. By combining, they form slaked lime, calcium hydroxide. And this reaction also released what? Heat. So what type of is this? Exothermic. Okay, let's go. What is the first thing? Rise in temperature. Exothermic reaction. Why? Because heat is released. The questions in exam comes from this only, so remember the pointers. Second thing, quicklime reacts vigorously with water. Reacts very fast. Released very much heat. Vigorously, rapidly, speedily, very fast, vigorously react. Water added slowly because reaction is exothermic. Add water slowly. Quicklime water in calcium oxide should be added slowly. Why? Because if added plenty of water, and too much heat released, the beaker in which the doing the reaction may blast. That's why water added slowly will be asked in exam. Why water added slowly? Because it is highly exothermic. If plenty of water added at once, too much heat will be released and beaker may burst. In the combination reaction, CaO plus H2O combines CaOH whole twice. So combination is there, two things are combining to form one. Also it is exothermic. Why? Because heat is being released. All right, where is quicklime used? Remember it, it's used to make cement. And slake lime is used in house for whitewashing in house. We'll teach you ahead. So all this point you have to memorize this. Where is quicklime used? In making cement. Slake lime will teach ahead. Where? In whitewash. Reaction must be memorized. CaO plus H2O combines CaOH whole twice plus heat. It's balanced. One calcium, two oxygen, two hydrogen, balanced. It's clear? Quicklime, CaO, slaked lime. It's slaked. Lake can be seen. Lime means calcium hydroxide. All right, let's go, bhai. Let's move ahead. Let's go next. Next is beta whitewash wall. Now what happens? The slake lime which was made, what we do? Paint on the wall. We paint slake lime on the wall and leave it for 2 or 3 days for painting. After we leave it for 2-3 days, then that slake lime, what it does? It absorbs carbon dioxide from around it. Then what happens? Calcium hydroxide, slake lime solution is used for whitewashing wall. It reacts slowly with carbon dioxide from air. We paint it like this and left slowly, what has happened? It starts absorbing carbon dioxide from the air. Now see, calcium hydroxide, slake lime, absorb carbon dioxide. Both combines to form what? Calcium carbonate. And what does this calcium carbonate gives? It gives bright walls. Must have seen na, when the house is whitewashed, it looked dirty while being whitewashed. Doesn't shine then. Because what happened after whitewash? The calcium hydroxide reacts with the carbon dioxide slowly and reacts to form calcium carbonate, which gives what? Gives bright wall alongside. Water is released. CaCO3 is formed in 2-3 days on wall. This layer of CaCO3, calcium carbonate, gives shiny wall. So that's how we give shiny wall. Whereas slake lime used in whitewash wall. Clear? Let's move ahead. What more examples of combination reactions are there? One is burning of coal. Coal means carbon. Carbon combines with oxygen and what does it form? Carbon dioxide. Combination reaction. Formation of water from hydrogen and oxygen. Hydrogen and oxygen combines together. What is formed? Water. What type of reaction is this? Combination reaction. CBSE 2023. What is the question? Select from the following a process in which a combination reaction is involved. Tell. Black and white photography. It was not taught in combination reaction. Burning of coal. Yes. What does happen in this? It is a combination reaction. Burning of methane. No beta. Digestion of food. No. What is taught from this? Burning of coal. No question beyond this will come. Don't tense. The next type of reaction is decomposition reaction. You saw in combination that two chemicals were combining to give one product. The reverse of this happen in decomposition. That one thing breaks and becomes two. Reverse of combination. What is that? One reactant breaks into two or more products. One reactant would break, for example, one reactant A break from what? Makes B and C. So it's just the opposite of combination. In combination, two things untie to make one new thing. In this, one thing breaks and makes two or more than two things. One reactants break into two or more products. See the example. We have calcium carbonate. We can call this limestone as well. We heated the calcium carbonate. We heated, and what happened after heating? It broke. What came out after baking? One calcium along with the oxygen. Calcium oxide, quicklime. When one calcium eloped with oxygen, then what remained? CO2. So what got released? Carbon dioxide. What kind of reaction is this? Decomposition reaction. One reactant broke and became two product. Okay. Quicklime is used in making cement. I have told you this earlier as well. Come, let's see. CBSE 2024. Identify the product X obtained in the following chemical reaction. Heat the calcium carbonate. So what happens? Calcium will take one oxygen and run away. Calcium oxide. What will remain? One carbon, two oxygen, carbon dioxide. So what is X? Calcium oxide. What is the name of calcium oxide? Quicklime. Bhai, directly game over. Now understand this. What is happening in decomposition reaction? In decomposition reaction, there is one reactant, and upon breaking, it's becoming two or more than two product. In order to break something, is the energy required or not? When your parents come and break you, does it take some energy or not? Do they break you or not? Bhai, we have also been broken. You will be broken too. We have been beaten. You will be beaten too. And when you are hit, then the tears come out, right? And then your parents hit more on that, mother especially. If you cry, I'll hit you more. I don't understand this. Now in silence, now stop. If you cry, one more. Now if you mistaken the bangle is broken, you are hitting by your own, your bangle is broke, then she'll hit more. You broke my bangle. And if by mistake you touch your mother while she's hitting you, like this, stop mummy, you will raise your hand against your mother. Were you born for this? Sir, how dirty you talk. What's that? It's biology, hair of nose. In decomposition reaction, some energy always consumed. We can give energy in three ways. One is heat form, we can give energy. When we give energy in form of heat, this will form thermal heat. Second, we use electricity. We use current. We use current to break something. We use current and it gets broken. When it breaks with current, then electrolytic decomposition. Third, we break something with light. Light is also energy. The light comes from sun, also an energy. When we break someone by energy, we call it photochemical decomposition. Don't you worry, we have to study all this in detail. So we either break it with heat or break it with electricity, current, or will break it with light. Energy will be needed to break. If we break by heat, thermal decomposition. If break by electricity, electrolytic decomposition. If we break by light, photochemical. Let's read one by one in detail. Questions comes from here. First is thermal decomposition. Decomposition means one breaks down to become two or more. Thermal decomposition or thermolysis means breaking of what? Breaking by heat. So this example, beta, is very important. It comes in board every year. What? We took crystal of ferrous sulfate. How are the ferrous sulfate crystals? They are green in color. Can you see it? Green in color. When we heat it, it will break down, which is heated. If heated, thermal decomposition. So it breaks down. What it becomes after breaking must be memorized first. Ferric oxide, Fe2O3. Second, sulfur dioxide, sulfur trioxide. It's very easy. SO2 and SO3. Two oxides from sulfur, SO2, sulfur dioxide, sulfur trioxide. All right. So this reaction must be memorized. See, this is balanced also. We heated the ferrous sulfate crystals. What color they were? Green color. After heating, what comes like powder? Ferric oxide. What color is it? Reddish brown color. And gases released are sulfur dioxide and sulfur trioxide. So this reaction and color must be memorized by us. What is it? Ferrous sulfate crystals, green color. Heated, breaks down ferric oxide, reddish brown, SO2 and SO3. Now let's read important points. First thing, ferrous sulfate crystals are green in color. True. On heating, it loses water and changes to white color. So beta, it doesn't become red directly from green. It has been asked in board. Directly from green to red, it doesn't happen. You have to remember the reaction first. Yes, you have to memorize it. First, it becomes white to green. And then when it's heated further, then it becomes red from white. There's the same thing written here. Ferrous sulfate crystals are green in color. On heating, it loses water and changes its color to white. First, it becomes white. On further heating, ferric oxide is formed, which is reddish brown in color. How does it become later? Reddish brown. With it, SO2 and SO3. Now listen, the smell of burning sulfur, matchstick. When you burn matchstick, isn't it smell after burning matchstick? Very good smell, sir. You don't do drugs all by burning matchstick. Burning matchstick, this is fun. So the matchstick's burning smell of the burning matchstick, smell of burnt matchsticks, the smell comes from this reaction. Whose smell is that? The burnt sulfur, smell of burning sulfur. Smell of SO2, suffocating odor or pungent smell. How is the smell? Suffocating. If you burn the matchstick and keep it close to your nose after extinguishing, the smoke that comes after extinguishing, all the nose hairs are burning. All the nose hair starts burning, na? Sir, how dirty you talk. What's that? It's biology. There is hair in nose. Those two have their own function. So that starts burning. Then how suffocating and pungent odor comes in this reaction? It might be asked in board, how's the smell? Suffocating, like matchsticks. Okay. SO2 and SO3 are released. These are air pollutants. Sulfur dioxide and sulfur trioxide causes pollution. And these are acidic in nature. What is the nature of these two? Acidic nature. Nature of acid. Then, if we take moist solution of this, it will turn into blue litmus to red. We will read this on his next chapter, acid, base and salt. Don't worry. But if this taken into moist solution, taken into water, then turn blue litmus into red. That's why acidic in nature. Okay, what is the reaction? Thermal decomposition and endothermic reaction. Now see, if heat is released in any reaction, it is exothermic. And if heat is absorbed, then it's endothermic. Here heat is being absorbed. This is taking heat. So whenever reaction is absorbs heat, then it becomes endothermic. And if the heat is released, so beta exothermic. Beta whatever decomposition reactions are there, whatever, in every one you have to broken. Decomposition reaction means one thing will break down into one or two things. Here we can see. When you break it, it requires heat and energy. All the decomposition reaction that you see, each one is endothermic and everything energy is required. That's why thermal decomposition and endothermic also, because what is happening in this heat reaction? Absorb. If the heat is got released, then it would be exothermic. See this, how to do this? This is Babita ji doing the reaction. You might have a Babita too. How is she doing the reaction? You have to take care of some of the things. What did you take here? You took the crystals of ferrous sulfate. She is heating the ferrous sulfate crystals. Do not point the mouth of boiling tube at your neighbor or yourself. There is this tube. Don't point the mouth of this towards your nose or your neighbor's nose, except when you have some enmity with the neighbor. In that case, you can make him smell a little. So why shouldn't you do it? Yeah, this is air pollutant gas. It's pungent smell. It will bother you later. So that's why you have to keep it away. But if you have to smell the gas, why do you have to test? We have to test the gases release. So wave it a little bit. The smell of burning matchsticks. Don't do it like this. Waving glass towards the nose, we have to wave a little. Don't point it towards your and your neighbor's nose. If they ask you in board, why not to do it? Because SO2 and SO3 are pollutants. The smell is suffocating. That's why you shouldn't do it. Clear its reaction. What is it an example of? Thermal decomposition and endothermic. Heat is high. What happened with green color? First, it's white. After heating it a little more, what happened? It became reddish brown. Ferric oxide. Acha, okay. Let's see further. Now, this reaction takes place in two steps. If you look carefully, the color changed twice. First, what did it become from blue to what? White. Then what did it become from white? It become black. So this reaction takes in two steps, and this is asked in board, and I teach it every year. Don't take tension. What's the first thing? We have hydrated ferrous sulfide crystals. What was ferrous sulfate? FeSO4. Hydrated means it has water too. So FeSO4 dot 7H2O. What color is it? Green color. Hydrated. Hydrated means it has water as well. When we heat this green color of ferrous sulfate, the crystal of water, FeSO4 dot 7H2O. When we heat it, then water gets out of it first. 7H2O is out. What remains? FeSO4. What has become? Anhydrous. Anhydrous. By hydrous means water and anhydrous means without water. What color is this? This is white color. Now, when we heat anhydrous ferrous sulfide, so it will be white in color. So it was white color, and what did it become from white? Reddish brown. So this was a two-step reaction. Step number 1, step number 2. So in exam, if they ask you both steps, so bhai, you should remember both of them. FeSO4 dot 7H2O, what is it? Hydrated ferrous sulfate crystals. I heated it, water got out. What remained? FeSO4. What color changed? Green to white. It went from green to white in first step. Then what is FeSO4? Anhydrous. Water is over. How is this? white. We have to heat it more, ferric oxide. How? Reddish brown. And what? SO2 and SO3. See, a question also came from 2025. What is it? What is observed when hydrated ferrous sulfate crystals are heated in a boiling and dry tube? What said? Which one? Hydrated ferrous sulfate crystals. It means it begins from here. Hydrated ferrous sulfate crystal. So what was we observed? That at first the color will go from green to white, by more heating from white to red. So what will be the observation? On heating the hydrated ferrous sulfate crystals, the color changes to white. On further heating, the color changes to red. You can also tell that some gases would remove which are pungent in smell, suffocating in smell, which smells like matchsticks, the smell of burning sulfur. Observation. What will we observe? By this is observation. First, we'll be able to see the color. What happened to the color? From green to white to red. Second, you will get the smell, a pungent smell. Give balanced chemical equation. See, the board was written S here. They know it too. There are two equations of the reaction, and here is wrote X. Reactions that occur, and here is S. So they know there is two. So we'll have both reactions here. First, you heated the hydrated ferrous sulfate crystal. Very easy. FeSO4.7H2O. Water is removed, FeSO4. Then when FeSO4 is heated, then Fe2O3, SO2 and SO3 will come out. Clear? Come, let's move ahead. Next question, CBSE 2025. List the possible sources of energy required in decomposition reaction. What are the possible energies which led to decomposition reaction? First, can happen with heat. Second, electric current can be done by electricity. Third, it can also be done by light. So what are the possible sources? Either heat it or supply current or put light on it. Illustrate any one with a suitable example. Show any one. So we showed one with heat. What? Thermal decomposition. If it's done by heat, then thermal decomposition of what? Of ferrous sulfate crystal. So I took FeSO4, green color, heated, ferric oxide, reddish brown, it formed along with SO2, so 3. Clear? Let's move ahead. Next is thermal decomposition of lead nitrate. We took lead nitrate, PbNO3, whole twice. What is the color of lead nitrate? White. You have to memorize colors. What color is it? White. I heated it, broke it by heating. We will heat it, then it will breaks. One thing comes out of it, PbO, lead oxide. Then comes NO2, nitrogen dioxide, and oxygen comes out of it. 3 products are formed. One thing was broken down by heat. Broke it down by heating. Cut. What will happen? Cut. What will happen? A cracking sound will be heard. What happened? Heated it. Tuck. What comes out? Lead comes out. Further heating it. What comes? Gas. NO2 gas. What came out? Oxygen gas. 3 products are formed. Look carefully into balancing of NO2 is 4. I had memorized you na that this reaction comes in exam. Just memorize the balancing of NO2 is 4. Rest you can do it by yourself. That's why I memorized it. Remember this reaction. What is to put in NO2? 4. Rest will be put on its own. So lead nitrate, PbNO3 whole times is heated. What came out? Lead oxide. What has came? NO2. What has come? Oxygen gas. Now let's understand the color and things. The lead nitrate is of white in color. It's of white color. When it is heated, a yellow residue of lead oxide is found. What? Yellow residue of lead oxide. A gas came out which gives brown fumes. What? Nitrogen dioxide. What else is formed? Oxygen gas is formed. Important points. Cracking sounds, kar, like sounds here. Brown fumes of nitrogen dioxide are found. How does it smell? It has irritating smell. Yellow solid residue is found. This yellow solid residue of what? Lead oxide. How is the gas of NO2? It's acidic in nature. Turns moist blue litmus red. All the things, beta, which are acidic will turn into moist blue litmus into red. We will study in this next chapter, acid, base and salts. Remember it, acidic. What is the example for? Thermal decomposition and endothermic. Why? Because here is also heat is supplied to it. When heat is supplied, when endothermic. You will remember this reaction. All right. NO2 comes out, O2 comes out, and lead comes out. What color is lead nitrate? White. Lead oxide, yellow residue. What comes out? NO2. Color? Brown fumes. What else comes out? Oxygen. Clear? Whose example? Thermal decomposition and endothermic reaction must be memorized. CBSE 2024. What's asking? The product obtains when lead nitrate is heated in a boiling tube. What products comes out? One is lead oxide, yellow residue in solid, and nitrogen dioxide gas comes out, brown fumes. What else comes out? Oxygen gas. So find out where is it? PbO, NO2 and O2. Option D is correct. Let's move ahead. The next way of breaking is, one is by heating. When broke by heat, what is called thermal decomposition. Read about ferrous sulfate, read about lead nitrate. Now breaking by current, only one is read in this, water. If we break water by applying current, then what is water? H2O, means formed by combining hydrogen and oxygen. So if electrolysis of water is done, if we break water by applying current, what do we have to do? What we have to use? Current, electric current. If we break water by applying electric current, then how it will break? This is water, this is liquid. Electric current is applied. So hydrogen will come out and oxygen will come out. Then you balance it. All right, you know how to break water. Hydrogen and oxygen will come out. Now it's about where it will come out. So what we do, we take a jug like this and a mug, whatever you take a plastic vessel, insulating, whatever you want, not pass current. We took in water in such thing. Now what we do, we put two test tubes here downwards. We put an inverted test tube. Then what we do, we put an electrode here. We put an electrode, graphite, such things. We connected an electrode here. With this electrode, we connected with a 6-volt battery. Now listen, the electrode connected with the positive terminal of the battery is called anode. The electrode which is connected by the negative terminal is called cathode. All right, do remember this one. One is connected with positive. The one which is connected with positive is anode. The negative which is connected is called cathode. Then we do heated it up. After heating, we saw this side. Oxygen came out on anode and hydrogen gas came out in cathode. Bhai, we pass current through it. Then they formed gas into it. Test tube inverted. So gas formed like bubbles moving upwards in the test tubes. By test tube was inverted. It had water. Gas was formed and started coming over water. Okay. What forms at anode? Oxygen. What forms at cathode? Hydrogen. Now there is a way to memorize it. Very simple. What? Pav. Do you eat pav? Burger pav. Memorize it from it. Pav. P means positive. A means anode. Which is positive? Anode. O means oxygen. It is simple. Look, what is forming at anode? Oxygen. How is anode? Positive. So electrolytic decomposition is broken by current. Or when we do electrolysis of water, then hydrogen, oxygen comes out in positive. How to memorize what and where they came out? With pav. The pav you eat, misal pav. All right, pav bhaji. Positive, anode, oxygen. So what is the positive? Anode. What comes from anode? Oxygen. Then what will be at the other negative one? Cathode. What will form on cathode? Hydrogen. You will remember this. Balancing it very easy. Why it's necessary? Please understand. I do ask you, at what volume hydrogen and oxygen is being formed? What is written before hydrogen? 2. What is written before oxygen? 1. So what is the volume of hydrogen and oxygen? 2:1. Remember it. What is the volume? 2:1. Means hydrogen and oxygen is formed. Like if I look here, what is the volume? Then this volume will double and this will be half of it. 2:1. If this is 2, then this is volume is 1. All right. Now see, if the same things are given, H2 gases is obtained at cathode and O2 gas at anode. You will remember it. POW. Positive, anode, oxygen. Talking about volume of gases, so what will be the ratio of hydrogen and oxygen? 2:1. One more thing is there that you can see no one has taught on the internet last year. I taught, and the question asked in the directly on the board 2025. Student has comment that you taught it. But everyone tells the ratio of volume. They don't talk about mass. What is the ratio of mass? If I weighed this gas, if I see its mass, then what will be the ratio of this mass? The ratio of mass for hydrogen to oxygen will be 1:8. The ratio of volume is 1:1. The ratio of mass 1:8. This is ratio of mass, and this is ratio of volume. You are saying volume is more, mass is less. Hydrogen is lighter. Oxygen is so much heavier. So 2:1 is the ratio of volume, 1:8 is the ratio of mass. Let's see further what is there. If I come with a burning candle, on cathode and anode, then what all we can see? At first we bought the candle at cathode. What does we have at cathode? Hydrogen. Whatever you have a burning candle, burning stick closer to hydrogen, then pop sound is heard. Do you understand pop sound? Look. This. A pop sound is heard. Why? Because hydrogen is highly flammable. Hydrogen is pure. So as you bring burning candle or burning stick, it means burning essence stick is brought closer. Where? Where? At cathode. Where is hydrogen? Suppose there is a leak of hydrogen from here. As the hydrogen leak here, then pop, it burns. And as it burns like pop, the essence of stick of candle is extinguished. Why does it extinguish? Because hydrogen itself burns, but there is no support of combustion. I will burn myself, but not let the fire spread. So what is it? Pop sound heard and candle extinguishes. Candle gets extinguished. Why? Hydrogen is combustible, but not supporter of combustion. It itself burns very fast, hard, but burns so fast that the fire extinguishes. Combustible, but not supporter of combustion. Next, I bought the burning candle at anode. What the gases cannot have? Oxygen, positive, anode, oxygen. Pow, positive, anode, oxygen. Oxygen is at anode. What is the game of oxygen? Oxygen burns nicely. Means it does not burn itself. It is a supporter of combustion. Sorry. Candle burns more brightly, rekindles a glowing splinter. What does oxygen do? If there is any fire anywhere, it boosts the fire. You must be knowing oxygen is a supporter of combustion. Oxygen is needed. If oxygen supply and cut somewhere, there will be no fire. So if I bring burning candle here, near anode, oxygen is here, so it will burn more playfully. If I burn essence stick here, then you have seen essence stick. What did it say? Splinter, glowing splinter. What is splinter? That you have seen a broom with thin stick. You must have got beaten by the childhood. Break a thin stick from it and burn it the way it burns. If the burning splinter is brought there, then buck, it will catch fire. Means rekindles a glowing splinter. Oxygen flames the fire. Candles burn more brightly. Oxygen is not combustible. It doesn't bright itself, but a supporter of combustion. If there is fire, then somewhere it boosts that. Hydrogen buzz like pop and extinguish. Oxygen boost the fire. One more point. In this whole electrolysis, pure water is not used. Remember it. The water you have taken in this electrolysis beta, you cannot take pure water. It is not pure water. Now, why cannot we take pure water, master? Understand this. It's not pure water. Why do we not take pure water? Pure water is a very poor conductor of electricity. Pure water doesn't conduct electricity. If it is distilled, then totally pure water, no current will flow through it. While we say current is a flow very fast in water, it's not in pure water. That's why we don't use pure water. Pure water is poor conductor of electricity. If there is some salt, some acid in the water, then it becomes excellent conductor. So a few drops of acid are added. Then acid acts as an electrolyte and allows the solution to conduct electricity. Simply understand, after adding acid, pure water turns into conductor. By the way, you can write this all, write in simple words too. We add a small drops of acid because pure water is a poor conductor of electricity. On adding small drops of acid, it becomes good conductor. Very simple. On adding small drops of acid, it becomes good conductor. That is why acid is added. See CBSE 2023 question. While electrolyzing water before passing the current, some drop of an acid are added. Why? Why is acid added? Already told you. Pure water is a poor conductor of electricity. To make it a good conductor, a few drops of diluted acid, like dilute sulfuric acid, consider as an example, are added before passing the electric current. Why? Because adding drops of acid makes the solution what? Good conductor. Pure water is a very poor conductor. That's why we add a little bit of acid and it becomes good conductor. Name the gases liberated at cathode and anode. Write the relationship between the volume of gases collected at the anode and the volume of gases collected at cathode. So always remember POW, positive, anode, oxygen. So this gas is getting from anode, oxygen. So it's obvious that the gas formed at cathode, hydrogen. Gas liberated at cathode is hydrogen. Gas liberated at anode is oxygen. What is the volumes ratio, beta? Hydrogen is to oxygen's ratio. Hydrogen and oxygen's ratio, what? 2:1. They have asked for the ratio volume. Volumes 2:1. If asked for mass, then 1:A. You could have tell this 2's ratio as a volume is what? Cathodes 2 and anodes 1. So write the volume of ratio as 2:1, or say the gas at cathode is twice the volume of gas obtained at anode. You can also write it, or you can write cathode is to anode 2:1. Anyways, fine. Anyways, let's go ahead. Next, we look at breaking something with light. With heat, we broke FeSO4, lead nitrate. Then with current, we broke water. Now we break with light. But when we broke something with light, we call it photochemical decomposition or photolysis. If broken with electric current, it's electrolytic decomposition or electrolysis. If I broke with light, it's photochemical decomposition or photolysis. See what is photo? Light has two natures, particle and wave. It is believed light is made of very small particles, which is called photons. It is believed that light is made of very small particles, that's called photon. That's why we call it photochemical decomposition or photolysis. Wherever you see photo, it means light is breaking by light. So there are only two reactions of breaking by light. One silver chloride, one silver bromide. Silver chloride is white in color. When sunlight falls on it, as soon as light falls, silver chloride breaks down. What does it form? Silver and chlorine. So we get silver and chlorine, simple. It's very simple. Photochemical decomposition of silver chloride. What color? White. What happens? We put sunlight, it breaks. One silver formed. Chlorine doesn't stay alone. Beta, it stays in gas form as Cl2 gas. So chlorine comes Cl2. Check balance, 2 silver, 2 chlorine, 2 chlorine. Now this silver chloride is white in color. When you put sunlight or light, it becomes silver. Silver, you must have seen, it's grey in color. You must have seen silver jewelry, it's grey in color. What was silver chloride? White. Silver is grey. Chlorine gas comes out in yellowish green. This is not in NCERT, it's not been asked, but still I wrote this, so it's extra. Okay. So what is AgCl? White in color. Then light falls on it, it turns into what? Silver grey color. There is a similar reaction like AgCl, silver chloride, just like that. AgBr, silver bromide. Silver chloride, silver bromide. Exactly same. When we put sunlight on it, it breaks. What we get? Ag and become C. Sorry. All right. Exactly same. What we get? Ag and bromine gas. Now, beta, tell me one thing. Why can't I keep silver chloride in black bottles? If kept in normal bottles, plastic bottles, then light will fall on it. It will break and turn into silver. Sometimes or the other in our life, we scientists need silver chloride. So in the labs, when we keep silver chloride, then it must be kept in those kind of bottles. When no light enters, then if light falls, it will break. So this is given. This is why AgCl and AgBr are kept in black color bottles to protect from sunlight. We keep them protected from sunlight. Otherwise, AgCl will never be found. It will always break into silver. Second thing, its use is been asked in board exam. What is its use? Its use is in black and white photography, for both black and white photography. So that's breaking by light. There are only two reactions. AgCl is decomposed, Ag and Cl2. AgBr is decompressed, Ag and Br2. AgCl is white in color and Ag is grey color. Let's go, bhai. Now look at the question. Related questions came in CBSE 2023. In 2023, what they have asked? Silver chloride kept in a china dish nothing but a katora, turns grey in sunlight. It turns grey. Write the color of silver chloride when it was kept in a china dish. First silver, it will be the color of silver chloride. Write the color of silver chloride when kept in china dish. Silver chloride was white in color when kept in china dish. Name the type of chemical reaction taking place. What is it? Photochemical decomposition or photolysis. The type of reaction is photochemical decomposition reaction or photolysis. What else is there? Write the chemical equation for the reaction. AgCl from sunlight. So we light in the presence of sunlight, or write the sunlight on top of arrow. What it becomes? Silver and chloride. All right. State one use of this reaction. Tell one usage of the reaction. What is the use? Black and white photography. The reaction is used in black and white photography. Name one more chemical which can be used for the same purpose. Tell one more. AgBr. You have the one more chemical is silver bromide. You have to write the name silver bromide, which can be used for the same purpose. Now we have to study displacement reaction. What happens in displacement reaction? More reactive elements replaces a less reactive element from its compound. Let us consider there is a reaction where Bc is a compound. Don't laugh. Okay, and A is an element. Now what A does, it's A enters in compound, replaces the B and push out and makes a bond with C, replacing itself. Then we can say A is more reactive than B. A is what? More reactive than B. We can call such reaction displacement reaction, where a more reactive element displaces a less reactive element, itself makes a compound, where a more reactive element replaces a less reactive element from its compound. Now the talk is, master, how and how will know that something is more reactive or less reactive? For this, we have to see the reactivity series through which we can know which element is more reactive, which is less reactive. In this series, to our top are more reactive and those below are less reactive. This element we have to study. Usually this series even longer, but a lot of elements are removed. Lithium is removed, chromium is removed, cobalt is removed, nickel is removed. We study the detailed reactivity series in class 11 and 12. We studied the smaller version, more reactive on top, less reactive at the bottom. Now we have to remember the metals and sequence. So to remember, we have to mnemonic code. What is it? कुरी नाल कार मांगो ऑल्टो, जिसको फिर लेकर हम चले मथुरा साथ घूमने. Kuri means potassium, Nal means sodium, Car calcium, Mango magnesium, Alto aluminium, Jisco zinc, then ferrous means iron. Lekar lead, Hum hydrogen, Chale. What is chalo? Copper. Mathura means mercury, Sat silver, Ghumne gold. So that means here, remember like this or remember like this, you have to remember. Now how you can remember this? Bhai, consider you have a friend and you have to take her for a date. Then what we do? We went to the bhaiya from class 12 and asked him for the scooter. I have to take my friend for the date. I don't know if you are that lucky. Only a few boys in the class are lucky. And you are jealous of those boys. Those boys who can talk very easily with girls. What do we call them? We call them something, na? Tell me in the comments. Hey, I will not tell. So bhai, what do we say? Please give me the scooter. Where will you go on a date? It's the same. So for Kuri, Kuri naal car mango alto. जिसको फिर लेकर हम चले मथुरा साथ घूमने. So you can remember like this if you want, or you can remember like this. I remember the complete activity series. What? Likba, Sarkana, Mug, Almanjan, Croak, Knee, Pub, HCU, HG, AG, AU, PT. Now see, this is not even here. Platinum, PT, when I said. Likba, lithium, Likba, barium, Ba. Everything's removed. So the list is very small. If you want, you can remember like this, or you can remember like the Corinal, Carl, Mango, Alto, जिसको फिर लेकर हम चले मथुरा साथ घूमने. Whatever is on the top is less reactive, whatever is in bottom less reactive. Whichever is more stronger will remove the less stronger. Do you understand anything? The world works like this. Remember that example, the one who has more money that removes the weaker and makes their own bond. Better, that's why I said very important is earning money. A lot of people say money is nothing, money doesn't matter in life. Remember one thing, beta, whoever tells you, beta, money is not important, the world doesn't run on money, beta, you will see this world will always judge you by the type of expensive cloth you wear, the type of expensive house you live in, the type of car you drive, the type of shoes you wear, the type of expensive school you go. I will tell you one thing. Human was made to love and money was invented to use, but the world uses humans and loves money. Wow, wow, master, you are a poet. Better remember that money is language that the world understands. When money comes, people's behavior and their opinions change for you. If you go to a wedding, you will see soon as a rich person enters, everyone runs after him. Saab, you will eat ice cream. Saab, you will eat kulfi. It doesn't matter he's a good or bad. The same happens here in chemistry. The rich one dominates. Come, let's see. First is zinc plus copper sulfate. Reactivity series I have written for you. Memorize it too little. Let's see. Where is zinc there? Here it is. Where is copper in this? Here. Zinc is more reactive than copper. The one is above that is more reactive. The ones that are below are weak. Now tell, if zinc is more reactive, then what would it do? It will take copper and throw it out. What will it make? ZnSO4 plus copper. This reaction is in our syllabus. We should know this. Copper sulfate is blue in color. There is much to remember. This chapter is like this. And zinc sulfate is colorless. It is not too much actually. It's C10-12 reactions. Copper base beta red or brown in color. We will read it later. This is the reaction. Why did reaction take place? I am understanding. Why did reaction take place? Zinc is more reactive, copper is less, so it's taken and thrown out. Next, zinc reacts with H2SO4 with sulfuric acid. See, where is zinc? This is, here is hydrogen. Is zinc more reactive than hydrogen? Yes, it's above that, it's richer. So it would take hydrogen and throw it away. It would enter inside ZnSO4. What else would be released? Hydrogen gas would be released in this reaction. Zn was more reactive, so remove hydrogen, it threw it away. Hydrogen was below. Next, Fe plus CuSO4, important reaction, we'll read it in detail. Now see, look at iron carefully. What is iron? Where is Fe? Here it is. What is the reaction with CuSO4? Here is copper. Is iron more reactive or less reactive? Tell me. Iron is more reactive. It is above. Since it's above, then throw out the below one out. And what will it make? FeSO4. And what else will it make? Copper. This is very important reaction. We'll read it in detail. Next is Cu plus PbSO4. You must have understood what we made directly of it. CuSO4 plus Pb. Say, is it here? Still we move ahead. It's done. You are trapped, beta. Are mere bhai, you are trapped. That's how we trap you. It's wrong. This reaction will not take place. It will not happen. Check the reactivity series a little. That is why I taught you the reactivity series. Look at the reactivity series carefully. Where is copper? Where is copper? Where is copper? Let's take yellow color. Where is copper? This is. Where is lead? Where is lead? Here is lead. Now tell me, is copper more reactive than lead or less? Less reactive. How is copper? How is it in comparison of lead? It's less reactive. It's lower in the series, right? Look at the series. Where is it copper? Where? Here is copper. It's below. What is lead? Above. So how will copper take lead out? He's a weak man, a poor man. How will throw it out? So beta, this reaction will not take place. Slap yourself by on your own. You have made a mistake. This reaction will not take place. That's why reactivity series is taught to find out which reactions are valid and which are not. Let's move ahead. This is a reaction. We have to remember displacement reaction. What? Activity 1 point. Iron nail in copper sulfate solution. So what did we do? We took nails of iron and put them in what? In copper sulfate solution. What is the color of copper sulfate? It's blue. Where is iron? It's above copper. Where is iron? It's in the above copper. So iron will take copper and throw it out. Copper got thrown out. Iron enters inside and forms FeSO4. You should remember this reaction. Where is iron? Above the copper. So it threw copper out and enter inside FeSO4. Now, what is the color of copper sulfate? Blue. What did it become later? Ferrous sulfate FeSO4. You read about it color a while ago. What it is like? It's green. Here it's not crystal, it's aqueous. Earlier it was crystal, now aqueous. So light green. Sometimes in exam it's called pale green also. No one will laugh. What is called? Pale green or light green color. What else came out? Copper. What is copper? Reddish brown. Red or brown will also work. Reddish brown. Now related to this reaction, an experiment is given in this NCERT. What is this experiment? Look at carefully. What is happening here? We took a tube. What's in the tube, beta? What is inside the tube? The solution of CuSO4, aqueous solution of CuSO4. What color it should be, beta? It should be blue color. What did we hang in it? An iron nail. What did we put in it? Iron. We hung Fe nail. We put iron in it. So what is in this nail? It's iron. What would this iron do? It would remove copper from the solution and would itself keep getting into the solution. So this iron, see this iron, this is iron nail. When it would enter the copper sulfate solution, then what would it do? It would throw the copper away and itself would get in. What would be the solution become? It would be ferrous sulfate. So see, what happened later? It was like this. It was like this in the beginning. But after some time, how did the reaction mixture become like this? What was in the beginning? It was solution of copper sulfate. An iron nail was hung it in. Iron nail means iron. Iron threw copper out of copper sulfate and itself got in FeSO4. What solution did it become? What solution did it become? FeSO4. What is the color? Green. So it will change from blue to green. Now the thing is, the copper that came out of it, where did it go? There was a copper sulfate in it. Where is the solution? Copper sulfate, blue color. The copper that got out, that will keep sticking to the iron nail, sticking. Iron nail will come to the incline and it will keep sticking. And in the end, you will see the iron nail looks like this. Iron nail taken out from copper sulfate solution. How did the nail become? When it got deposited, the copper deposit. That is why, how does the nail look? What's the color of the nail now? Reddish brown. Is it clear? The iron nail was put in copper sulfate. What is like blue? Then the iron entered it and copper got out. What did the solution become? What did it become? FeSO4. The solution changed from blue to what? Green. And the copper that came out from the solution, where did it go? On the nail. Copper got deposition on the nail. Copper is there on the whole nail. The copper color is reddish brown. So the nail too reddish brown. Will you remember? Copper sulfate went from blue to green and the copper is red in color. Why it happens? Because iron is more reactive than copper. Displacement reaction. See, what is this question on this? 2025, a question came. What is it? A student has dipped some iron nail in an aqueous solution of copper sulfate. After about 25 minutes, he would observe that the color of the solution has changed from. What would be the color of the solution? Earlier it was copper sulfate. Iron will react with it. What will it become? It will become FeSO4 and copper will come out. So color of solution, what was it? It was blue. And what was it? Light green, pale green or something. So what will it become? Blue to pale green. Is it correct? Whether it's written as light green or pale green, from blue to green it will become. Clear? Let's go. Next is zinc reaction with sulfuric acid. Now tell me whether this reaction takes place or not. Quickly see the reactivity series. This is the reaction they're asking in the exam. It's important. Now see whether this reaction will come or not. See this. Everything is important beta, whatever is taught. This question will come from this lecture. Where is hydrogen here? Zinc is more reactive than hydrogen. It's above, it's more reactive. It will throw the hydrogen out. And what will it make? ZnSO4. And what else will release? Hydrogen gas will release. In this reaction, there are some observations. First, what we get? Hydrogen gas. What did we get? Hydrogen gas. What is like? Colorless, odorless. Neither has it smell nor its color. Burns with a pop sound. Told you na, hydrogen burns with pop sound. And extinguishes a burning candle. It will extinguish a burning candle. Why? It is not the supporter of combustion. Temperature increases. The reaction is highly exothermic. What else is getting released in this reaction? Heat is getting released. It's highly exothermic. Dilute acid is used because the reaction is highly exothermic. Means concentrated acid would make it even more exothermic and dangerous reaction. Dilute means with a little water. What kind of acid is used? Dilute. See, aqueous is written. The acid is a little bit of water. A very kara acid. What is it? Concentrated acid. It's not use water in it. Why? Because heat is getting released. If you use concentrated, then lot of heat is released. A lot of heat is released, then glass will blast. So this is written, dilute acid is used because reaction is highly exothermic. Concentrated acid would make it even more concentrated. Absolutely, kara acid. Dilute means light by adding little water. Dilute it, make it light by adding water. Let's move ahead. CBSC 2022. Study the diagram given below and identify the gas formed in the reaction. See the diagram, what is it? Dilute sulfuric acid, zinc granules. What are they asking? Which gas would be released? Identify the gas formed in reaction. So dilute sulfuric acid means H2SO4 aqueous. What we are making in this? Zinc granule. Zinc plus H2SO4. What will happen? Zinc is more reactive. ZnSO4. And wet gas will get released? Hydrogen gas. Carbon dioxide, no. Oxygen, no. Sulfuric acid, no. Hydrogen, which on burning produces a pop sound. Let's move ahead. The last type of reaction is double displacement reaction. You must have seen in Akshay Kumar meme. It's old thing. That's one. This happens. It means both things will get displaced. Double displacement. There was just one displacement, double displacement. Suppose this is a couple. This is a couple. They got bored of each other. They too, nowadays people get bored in relationship. Bhai, people said, so let's exchange. This was a couple, plus on A, minus on B. This was a couple, plus on C, minus on D. So this plus got attached to this, and this plus got attached to the minus. So A went get attached to D, B got attached with C. So what happened here? It exchanged. Need a substitute, not displaced, but it exchanged. What got exchanged? Ions between reactants. Don't write atom. Sometimes in exam they ask if atoms got exchanged. No, not at all. Did the molecules got exchanged? No. What got exchanged? Ions got exchanged. Ion means positive ion, negative ion. A plus B minus C plus D minus. This got attached in minus, this got attached in this minus. So AD and BC. This is an example, Na2SO4 BaCl2. See what happened? Now see how to do that. Na plus sulfate is minus, Ba plus Cl is minus. So Na attached to Cl, NaCl, SO4 minus attached Ba, BaSO4. So we study in detail. For now, did you get this example? NaSO4 plus Na plus SO4 minus BaCl2, Ba plus Cl minus. So this is plus got attached to Cl and this was got attached to SO4. So BaSO4, NaCl. We study this in reaction in detail. This is important. Okay, let's study ahead. Now we have to study two examples of double displacement. First is reaction of sodium sulfate, double displacement. Reaction of sodium sulfate with barium chloride. This is sodium sulfate, Na2SO4. Aqueous means in water. What it's like? Colorless. The second one is barium chloride. Aqueous means this is 2 in water. What is it? Colorless. Now see, this is plus, this is minus, this is plus, this is minus. Na attached to Cl, B attached to SO4. Na attached to Cl, B attached to SO4. What is special? This is BaSO4, which is formed, let's say, white precipitate. Precipitates, I should have told you in the beginning, what are they? Insoluble in water. What did it become? Insoluble in water. Look at this. This, what we do? We add sodium sulfate in it and this barium chloride. When we mixed both of them, then we saw there is no clear solution was formed. The solution is not clear. Why? Because some white precipitate, look here is some insoluble white precipitate was formed. What is it? Barium sulfate, BaSO4. White precipitate was formed below. No clear solution. Is it clear? Na attached to Cl, B attached to SO4. What is BaSO4? White precipitate, insoluble in water. What is NaCl beta? Aqueous. Aqueous means soluble in water. This is soluble. What are the observation? White insoluble substance. What it is called? Precipitate. The insoluble one, precipitate of barium sulfate is formed. White solubles. White insoluble precipitate was formed. Double displacement and precipitation reaction. It is not only example of double displacement. This is double displacement too, but what else it is? PPT, precipitation reaction. Now what is precipitation reaction? The one in which there are two. Aqueous, aqueous. That means soluble, soluble. Aqueous means water soluble. Aqueous means water soluble. Such a reaction in which two soluble, soluble things combine and an insoluble thing is formed. That reaction is called precipitation reaction. This is precipitation reaction. When two aqueous soluble solutions, react to form a semi-soluble or insoluble salt. Either it would be semi-soluble or insoluble salt. The salt is called precipitate. What is it? Insoluble. What is it called? Precipitate. And such reaction is called precipitation reaction. So when there are two double displacement reaction in your syllabus, have two and two precipitations example. So wherever double displacement is seen in your syllabus, precipitation is also seen. Precipitation means precipitate was formed, so precipitation. When two aqueous soluble solutions react to form a semi-soluble or insoluble salt, the salt is called precipitate and such reaction is called precipitation reaction. This is very good question. Ions in solutions. Now they are saying that when a reaction has taken place, then the solution after it taken place, the solution, which ions are in it. Now see, after the reactions, ions in solution, that is, when I have to tell this, after reaction, what are the ions? After the reactions, you will have to look at this side. There is this ion of barium and another of sulfate. What is sulfate like? It is negative. there is one of sodium and one of chloride. So this will all these ions. No, better these irons are not found. They are insoluble. So there's a guchu and form like this. This iron will not break because this is insoluble. So this will become precipitate and set down. The one which will not become precipitate, which is aqueous, that will form an ion. So if asked in solution, then the aqueous part, the one that is soluble, ions will come from that. So what would be ions? What is Na plus? What is Cl minus? So what are the ions? Na plus and Cl minus. They have asked this question in the board. They can ask it later as well. CBSE 2025. What is the question? What is observed when aqueous solution of sodium sulfate is added to aqueous solution of barium chloride taken in a dish tube? Write chemical equation for the reaction. We'll do it. It's simple. What is it? White insoluble substance or precipitate of barium sulfate is formed. They have asked what observed. What is observed? So, bhai, only this is observed that some insoluble precipitate was formed and this is balanced reaction for it. You will do it. Come on, let's move ahead. Second reaction which is in syllabus, double displacements, it is lead nitrate and potassium iodide. Lead nitrate, PbNO3 whole twice. How is it? Aqueous, that's soluble. What is it like? Colorless. Second, potassium iodide, Ki, right? What is like? Colorless, aqueous, water soluble. Plus came on this, minus came on this, plus come on this, minus came on this. So Pb got attached to I, PbI2 was formed. K got attached to NO3, KNO3 was formed. Now, why it's I2? You had to do it like this by, as I taught you, valency of lead is 2 plus, iodide is -1, cross multiplied PbI2. So this is formed. Okay. So Pb plus attached to I, PbI2, K plus attached to NO3, KaNO3. Now, the PbIb which is formed, what is it called? Yellow precipitate. Lead iodide is yellow precipitate, means insoluble in water. See beta, in syllabus there is a lead oxide yellow residue, another lead iodide which is yellow precipitate. Lead iodide is yellow precipitate and KNO3 beta, it's beside, remember this, what is it? Aqueous, this is water soluble and this is insoluble. Let's go. So what is the observation? Yellow insoluble substance precipitate of lead iodide is formed, PbI2. Lead iodide, double displacement and precipitation reaction because a precipitate is formed. Two soluble together made one insoluble salt, its precipitation and double displacement as well. Ions in solution, will there be ions of this? No, this will become soil below, it will be insoluble below. This one will have ions K plus NO3 minus. So what would be the ions for? K plus and nitrate, NO3 minus. Clear? Next is heat in reactions. So beta, either the reaction will release the heat or absorb it. If the heat gets out of reaction, then I have taught you this. If heat is released, then it is called exothermic. So if the heat is released in the reaction, then it's called exothermic. See an example, respiration. Respiration, some people think is just breathing. Breathing is not respiration. You eat the food and the energy made by it is called respiration. So the carbohydrates in your body, what you eat rice, you eat bread, you eat potato. Why do people eat? Cup. People eat to get energy. So this is the process of body. Carbohydrates become glucose and from glucose to energy. This is called respiration. So what does the glucose react to? It reacts to oxygen. And what does it make? CO2, H2O and energy. What kind of reaction is it? Exothermic. So remember, what is respiration? The energy that produced in the body. It's not breathing, so the energy that gets with food. So glucose reacts with oxygen and forms this. Next is beta, burning of natural gas. What have we taken here in natural gas? Methane. So when methane burns with oxygen, then carbon dioxide, water, heat, exothermic. Decomposition of vegetables into compost. What do you do, bhai? That the leftover food at home, the leftover vegetable at home, what do you do with them? Mix them with soil, that food become decomposed. What does it release? Energy released. Burning of magnesium ribbon, you must have read this, heat is released. Quicklime with water, calcium oxide and water combination reaction along with heat, so it is exothermic. Endothermic are those reaction beta in which heat waves happens to absorb the heat. The reaction that absorb the heat, that is endothermic. There is a very simple example of endothermic beta in your syllabus. All of these decomposition reactions, all of the beta, whether from heat, either from light, from electricity, everything that takes energy. All, it's very simple. Would be the example of this. Endothermic means that to absorb heat, to take energy. So decomposition of FeSO4 crystal. What do? We used to heat it, ferric oxide, sulfur dioxide, sulfur dioxide. The heat calcium carbonate, CaO2, CaO2. Lead nitrate, do one thing, take it as homework. What would happen? It will be practice. Memorize all the reaction. PbO, NO2O2, AgNCl2, AgNBr2, H2 O2. So what are these? Decomposition. If you want to write strongly correct things, then these three are always be right. Because what are these? Thermal decomposition. Because they broke only with heat. So these are the safest one with this. Rest are also there. Sometimes they ask in exam that every decomposition reaction are endothermic. They have asked in board. Okay, let's go ahead. CBSE 2022. What is this? Glucose combines with oxygen. What does it release, beta? It's respiration process. I told you na. What does the carbohydrate form first after getting inside the body? Glucose, all the rise that you eat. What does the glucose form with reaction with oxygen? This along with heat. And what kind of reaction it? Exothermic reaction. Simple. Next, select the endothermic reaction from the following. Decomposition, what is like, beta? Exothermic. When you put vegetables in mud, then you get energy. Decomposition of calcium carbonate into quicklime. I have told you whatever the decomposition reaction is, endothermic, over, directly over. Burning of a candle, no, beta. Process of respiration, respiration is exothermic. So whatever your decomposition reaction seen, then endothermic, because heat would be absorbed. Let's go ahead. The next, beta, is topic of oxidation and reduction. It's halwa, it's very small, relax and understand. Beta, if some chemical gains oxygen or lose the hydrogen, so we say the chemical has gone through oxidation. Simple. If a chemical gains an oxygen or loses hydrogen, then we call it oxidation of chemical A. Oxidation means gain of oxygen or loss of hydrogen. This opposite, reduction. If a chemical gains hydrogen or loses oxygen, then what do we call it? Reduction. If a chemical gains hydrogen or lose oxygen, it is called reduction of B. Is it clear? If something gains oxygen, then it's oxidation. Okay. And if something gains hydrogen, then reduction. Along with this, understand the opposite as well. If oxygen is gained or hydrogen is lost, then also oxidation. If hydrogen is gained or oxygen is lost, then to reduction. Okay. Will you remember? Come, let's do this. Let's go to this side. Tell me what went through oxidation, what went through reduction. Think. Here is zinc oxide. If I look at zinc oxide, then what did it do? It lost oxygen. Loss of oxygen. Loss of oxygen, oxygen is gone, so oxidation is not here. Oxidation, there is gain of oxygen. So what would loss of oxygen be? Reduction. Let's go. Let's look at the carbon now. Okay, reduction can we clearly see? What is it? Reduction. Let's look at the carbon now. From here to there, what did the carbon do, beta? Gain of oxygen. And gain of oxygen, to gain the oxygen, that is what? Oxidation. Okay. Now try to understand one thing. The one that got oxidation, that become reducing agent. Very simple. The one that got oxidized, that become reducing agent. And the one that got reduction, that become oxidizing agent. Topsy-turvy. Simple. The one that goes through oxidation, they sometimes ask in exam, which one is oxidizing agent, which one is reduction. The one that gets oxidized will become the reducing agent. The one that gets reduced will become oxidizing agent. Reducing agent, R.A. Oxidizing agent, O.A. The one that gets oxidized will become the reducing agent. The one that gets reduction, that will become oxidizing agent. Now let's understand the thing. Understand this. Oxidation of carbon happened. Yes or no? Gain of oxygen. Who did the oxidation of carbon? Who is the agent who does the carbon oxidized? Is it this? This has given oxygen to carbon and oxidization happened. Is this the agent which did the oxidization of carbon? Then will I not call this oxidizing agent? I definitely will. Carbon, now look at this. What happened to this? Reduction. What happened? Reduction. Loss of oxygen. Who took the oxygen away? Carbon. Who did its reduction? Carbon. Ain't carbon the reducing agent then? Definitely. But you don't have to understand that much. Simple. Whom oxidation happened, that become reducing agent. The one that gets reduced, that will be oxidizing agent. It's clear? You got it like this. What happening to this reduction? Loss of oxygen. So what's happening? Reduction. Who did the reduction? He took the oxygen away. So the one who did this is the agent. Which one? The one doing the reduction of this one is the reducing agent. Or just remember it simply, the one that gets oxidized will be reducing agent. The one that gets reduced, that is oxidizing agent. Okay. Try to understand one more thing with redox reactions. Such reactions in which both oxidation and reduction takes place, that is called redox reaction. A reaction in which oxidation and reduction occur is called redox reaction. Look at this redox reaction. This gone through reduction, this gone through oxidation. So this reaction is called redox reaction. Redox reaction. If there is both oxidation and reduction happen, that is redox reaction. Reaction in which oxidation and reduction occurs. Come, let's do a question. It is question of CBSE 2024. What are they asking? This is the question. Tell me, in this, who is oxidized and who got reduced? Come, let's pause, do it yourself in the comment, then you will understand. MnO2, if I see it went here. If I look at it carefully, then what's happening with this? Loss of oxygen is happening with it. What is happening with it then? Reduction is happening. I look at HCl carefully. What is made from HCl? Cl2 was made. What's made from it? Cl2 was made. If I look at it carefully, then what happened to it? Array, what's such happened? If I look at it carefully, then what happened to it? Loss of hydrogen happened from here to here. Loss of hydrogen, it's not reduction. To lose reduction means gain oxygen. That means what is happening to it? Oxidation. Tell me it's clear. Oxidizing is the reducing agent. Can you tell us? The one gets reduction, that becomes oxidizing agent. The one get oxidation, that becomes reducing agent. Whatever the question, I can do it. What is saying? MnO2 is oxidized? No. HCl is oxidized? That's correct. MnO2 is reduced? That's correct. MnO2 is reduced and HCl is oxidized. That is more correct. The more correct is half, na? The more MnO2 is reduced, HCl is oxidized. HCl is oxidized. Next is beta oxidation of copper. If I take copper, what color is it? Red or brown? If I told you copper color is red or brown. If I heat it, what do we put here? We put a wire gauge here. Wire gauge means something, you got it now? Wire, you put it here. If I heat it from below, heat it from below, heat it from below, then what will happen, beta? If we heat the copper around, then what will happen? It has oxygen around it. Then what is this? Copper. Copper will combine with the oxygen, and what will it form? Copper oxide when upon heating. When did it become copper oxide? What happened to copper? Gain of oxygen happened. Gain of oxygen, that is oxidation of copper happened. That is why we call it oxidation of copper. Remember the color. The color of copper is red or brown. When it gets oxidized, then it becomes black. So it becomes black color, copper oxide. So it's simple, reddish brown copper metal changes to black color copper oxide. Okay. Now see, if we reverse this reaction, oxidation is happening. If we have to reverse it, then what to do? Tell what have to reverse it. Let's do reduction. So if hydrogen gas is passed over CO, now what did I do? I passed hydrogen gas to it. What hydrogen gas do? It would snatch the oxygen from it. I snatched the oxygen, but it became H2O and became copper. Now see what happened to this reaction. What did copper do? Loss of oxygen. What is this? Loss of oxygen. Meaning, what is this? Reduction. So if we just reverse it, then this reaction get reversed to. We burned copper and oxygen, copper oxide. What happened? Oxidation. What happened? How do the red-brown copper become? Black. Now if I have to reverse it, oxidation occurred. What do we do for reverse? Reduction. Reduction is gain of hydrogen. If I pass through hydrogen and heat it, then what will happen? Hydrogen went away from oxygen. Copper lost the oxygen, and what did it become? Copper. So this black colored, what did copper oxide become again? Reddish brown copper metal. We just saw the reverse reaction of this. We have just seen. What do we have to do of oxidation? Reduction. Pass the hydrogen gas, it took the oxygen away, made copper. Clear? Come, CBSE 2025. Copper wire on burning flame gets coated with a black substance. There is a copper wire. What will happen if we burn it? What will happen? It gets coated with a black substance. Write the chemical equation of the reaction that takes place. So, bhai, this is a copper wire. What we do? We burnt it. After burning, it combined with oxygen and become copper oxide. How should the copper wire be? Reddish brown. Upon burning, what did the copper oxide become? Black substance. Here is black substance, copper oxide. How can this chemical change be reversed? How can we reverse it? What is it? Oxidation. If I have to reverse it, what we have to do? Reduction. Reduction is gain of hydrogen. If I pass copper oxide with hydrogen gas, then if I beta heat it, then what will happen? It will take away O and then again copper. So black color to reddish brown. Just reverse it. What happened to our oxidation? A reduction, gain of hydrogen or loss of oxygen. Like look here. Clear? Next is corrosion. So beta, what happens in corrosion? When a metal is attacked by substances around it, such as moisture, like water vapor, oxygen, acid, etc., etc., corrode, and this process is called corrosion. At home, you must have seen all the metallic things with time upon them. As you see this iron, it gets rust. It becomes red. With time, it corrodes. What is corrode? Something comes in, attacks on them. Who attacks? Whatever it is in the surroundings. What is it by? There are gases, water vapors. There is carbon dioxide. There is hydrogen sulfide. So all these gases in surroundings, what do? They attack on the metal surface and they keep sticking on it. These things is called corrosion. When a metal is attacked by substances around it, such as moisture, water vapor, oxygen, acid, carbon dioxide, or anything, it is said to corrode. Corrode means go bad. And this process is called corrosion. Is clear? When substance from the surroundings attack on it and it corrodes it. The first example is rusting of iron. This is an iron nail. There must be oxygen in the surrounding. There would be water vapors too. Both of these things go and stick on it. And it makes what? Rust. What is makes? Rust. What is the color? Reddish brown color. It is also called hydrated iron oxide. We will study it properly in metal and non-metal later. Reddish brown. Rust is formed of which color? Reddish brown. Oxygen and water attacks. Next is beta tarnishing of copper. What is the color of color? You have read it, red. It's get tarnished and become green. When the Statue of Liberty was made, it was red in color. Today, if you see, it's green in color. What happened to this beta? A kind of corrosion has happened. It's called tarnishing. Corrosion means if it's iron, then it's called rusting. If it's copper, then it's called tarnishing. Who attacked the copper? Oxygen, water vapor, carbon dioxide. What it forms? Some kind of compound was formed. What is the color? Green in color. Copper hydroxide, copper carbonate. So here it becomes, that's why it's green in color. Tarnishing of silver. Doesn't it happen in silver? Mummy gets it polished. When it turn into what? Turned into black. Why did it turn into black, bhai? Gray to black color. This should be have been black. Gray to black color. So what is this by silver metal? Above it, hydrogen sulfide, oxygen will attack from the atmosphere. Silver sulfide of black color is formed. So what is it? Gray to black. You must remember the color. Red to green, gray to black. How does iron become? Red it becomes. All right. Okay. Corrosion is an example of oxidation. Who the example is it? Oxidation. Look, oxygen is attacking this. Oxygen is attacking this also. Iron is also what is attacked? Oxygen. So example of oxidation. Next is rancidity. What is rancidity, beta? You must have seen at home. You bought chips, opened the packet, ate it, and suppose you went back to play. Again, you came back and eat chips. Taste is very bad. Suppose you let the chips remain open. You ate it after 1 day. Arey yaar, it tastes sour now. It's no more crispy, no more crispy. So this is called rancidity. What happens? Chips or any other edible contains oil. That's why you should not eat too much palm oil is there. Oil. This oil gets oxidation. When oxidation has happened, then this is called rancidity. What does it happen to? The taste or smell of food material containing fat or oil changes when it is left exposed to air for a long time. Understood? The taste changes. A bad smell also starts coming. It went bad, no longer crispy, rotten. Containing fat oil changes when it left exposed to air for a longer time. What happens? Oxidation of fat oil present in food material causes rancidity. What happens? Rancidity happens. This food gets rancid. it gets sour, gets rotten. Why? Because the oil in it, it gets oxidized. Now comes how to protect it. The first way is to put close to high antioxidants. These antioxidants like your almond, turmeric and all these things are antioxidants. Now what do antioxidants do? They don't let getting oxidized. The first way thing is to put antioxidants which prevent oxidation. What is second? Use the airtight container. Totally airtight. You have seen namkeen moms put an airtight container. So air doesn't go in, and if oxygen doesn't get in, then oxidation will not happen, the oil fat. So airtight container. Third, you must have seen what is in the chips packets. More air, less chips. So what do they fill in the air? Nitrogen. What are the chips bags? Flushed with nitrogen gas. Why do they fill nitrogen gas? So inside oxygen gas couldn't enter, and the oil on the chips inside doesn't get oxidized. That's why it's totally tight, totally nitrogen gas. So these three ways: put antioxidants, use airtight containers, or flush with nitrogen gas, so that rancidity can be prevented. Your last topic is chemical change or physical change. It is very simple, beta. Chemical change means it is any chemical reaction happen, then it's chemical change. And what was meant by chemical reaction? Chemical reaction meant the formation of new chemicals. If there is a new chemical formed, then it is chemical change, otherwise it is physical change. Any questions is exam have been asked, chemical change or physical change? If any new chemical is formed, then chemical change, but it's not coming in board. It's very long time it's not coming, but still I'm teaching you because it's in your book. Shape, size, color may also change. New chemicals are formed, like burning of paper. Beta, if you burn paper, carbon dioxide gas is formed and released. What? It's a new chemical. Fermentation of grapes. What there are grapes, beta? The sugar in grapes. Grapes are sweet, na? Alcohol is made from it. Yes, alcohol is made. Dirty thing. Souring of milk. What happened in milk, beta? Milk is also contains a different kind of sugar. Does it get sour? It gets sour. There is a different kind of sugar which becomes lactic acid. The sour taste, it's lactic acid. The same thing happens to curd. You already saw the rusting of iron, that oxygen and water vapor attacks on iron to form a new compound, hydrated ferric oxide. Food digestion, you already saw a few minutes earlier that different chemicals mix with food inside, then respiration happens. Food cooking, there are different gases came out. Respiration, you have seen it already. That glucose, what happens? Breaks down and become carbon dioxide and water energy. Chemical batteries, you have seen, beta, that chemical energy that changes into what? Electrical energy. You have seen baking of a cake. So beta, baking of cake, there are different kinds of chemical reactions happens. Next is physical change. Simple bhai, when no new chemical made, no new chemical are formed, where chemical reactions are not happening. Just like boiling water, water boiled, and what is happening? Water is H2O. Water vapor is become what? H2O. Then chemical change. Melting of ice. Ice becoming what? H2O. And water becomes what? H2O, new chemical. Melting of wax, remember this. Burning of candle is chemical change. Must remember why? Because candle is burning. So burning of candle is chemical change. But melting of wax is what? Physical. Because what is wax? It was in solid state. And from solid state, it melt away to liquid state. So melting of wax is physical change. But burning of candles is chemical change. Remember. Why? Because burning of candles releases carbon dioxide gases. Then what is it? Crushing of paper, folded it, shape, size change, crystallization, something becomes crystal. So beta, here this chapter ends. If anyone has written down the lecture and write in the comment, bhai, I will win, and tell me if you understood this chapter or not. Now go and solve all the questions. Keep studying. All the very best.